that we want to talk about here is the software development process, called the software development lifecycle sometimes, or at least I learned it as the software development lifecycle. And this shows you the entire phase of going from a software of some kind being requested to it actually being deployed live and then maintained. And there's quite a bit. It starts with someone requesting something. Usually a requirement or request of some kind comes in from someone. If you're working in a large corporation, it could be from some department. We get these all the time. I work for Sutter Health. We get requests all the time from doctors and or nurses or some of the business departments like HR for something they need. And then once the request comes in, it would be the job of, depending upon how you're dealing with it and how you're structured, you have software engineers who are expected to be able to do the entire life cycle, which is everything from requirement specification down to maintenance. You have computer programmers who really only do the build. And you've got project managers that do most of it, but they're not technical, so they don't do the build. They probably don't do the design either. They may be involved in the testing, though. And then you've also got something called a systems analyst, who specializes in just the early stages of the requirement specification, the systems analyst, and maybe some of the design. So there's different roles and different people that play in these things. And you can also have people that are dedicated to testing. That's all they do is testing. A lot of large corporations have dedicated testers, QA testers. And my experience is that's a really good idea. There's also people dedicated to just documentation. You don't see it on this life cycle because it's usually a side task. It's more of a side task. And unfortunately, unless you have someone dedicated to it, it is treated as a side task, which is not a good thing. And then, of course, even larger organizations will have a separate set of programmers doing the build versus doing the maintenance. They'll have maintenance programmers and developers. So depending upon the size of the organization, this could be a lot of different people. If it's a smaller organization, it might be one or two people. Not unheard of for it to be one person, which is not really a good idea, but it happens. So we start with the requirements, and the systems analysis is really where someone goes in and looks at the requirements and figures out what it'll take to build it, how much it'll cost to build it. Might look and see, is there something out there we can buy instead of building it? And ultimately, once a decision is made of buy versus build, or they may do the design anyway, because a lot of times if it's a very complicated system, they have to go as far as the design to determine if there's anything out there that they can buy versus build. So if the decision comes to build, or to buy really, then you go into what they call the implementation stage. The implementation stage, when you buy something, is where you're working with the vendor and you're meeting with the vendor to determine what it's going to take to install their program on your systems and get it working. And this isn't like Microsoft Word where you double-click setup and click next, next, next. These are generally large, complicated software programs that have to integrate and work with other systems. So, for example, in healthcare IT, if you're buying a new radiology system, it's got to be able to exchange data with your cardiology system and your registration system and your main clinical system, and it's very complicated. So we're not talking about Microsoft Office. We're talking about something far more complicated. The implementation is also where the build would happen if you decide to build it. And this would be done primarily by computer programmers and would be written in something like Java. When you're getting ready to test, and testing really here should be broken out into three different types of testing. There's what we call the beginning testing or the functional testing, where you build a component and you test it. And then when you have all the components tested, you kind of put them together, and that's known as integration testing. When you get the thing well tested enough, then you turn it over to your users, or the end users that are going to say, yeah, this thing works and it's what we want. And they do something called user acceptance testing, the final stage of testing. So testing should be broken out into different phases. Also, what's not covered here very well and should be talked about is the fact that this is what we would call an iterative process. By iterative, I mean You build the thing and you start testing it and you realize, oops, something's not quite right. You come back and you fix it and you come back down again. And it may be so wrong that you have to go all the way back and redesign. That's kind of bad. Hopefully you don't have to go all the way back to the analysis phase, but I've seen that happen too. But typically, some of in the testing, it'll be iterative between implementation and one of the testing phases. When you get to UAT testing or the user acceptance testing, the user may say the same thing and say, "Oh, that's not what I want. I really wanted it to do this." At that point, you may actually go back as far as system design if it's pretty major, or maybe you just go back. It's not that different. It was 90, 95% what they wanted, but they wanted a button moved over somewhere else, and they wanted a title changed slightly or whatever. So it's fairly simple. You go back to the build, and then it's testing. So this is what we call an iterative, which means the opposite of iterative is the waterfall. And in waterfall says it's basically one way. You only go this way. Iterative is two ways, and it's usually two ways between testing and system design and implementation. Waterfall is a joke. No one uses waterfall. Unless it's extremely simple, no one's using waterfall. Everyone uses iterative. Because there's no way you're going to get... For waterfall to work, that means you've got to get all these phases exactly correct the first time. And that never happens. So most are in an iterative phase, and it's generally in here. Right? And then you get down to deployment. So after it passes testing and everyone says, yes, it works, it's great, let's start using it, then you go into a deployment phase, which is usually a final meeting to make sure you've got all your I's dotted and your T's crossed and everyone signs off and says, yeah, it's ready to go, and management says, okay, we're satisfied, go ahead and deploy it. Then you deploy it, you go live, and the deployment phase may last anywhere from a couple hours to, if it's a really big system, a couple of months. I've seen that happen. And then finally, eventually goes into maintenance, which means it's deployed, it's stable, they're using it, no real issues, we're just going to maintain it now. And of course, this whole process can start over again if you get to a point where you make a major release or change in the software, then you go all the way back again and do it again. So this is generally the software development lifecycle, and there's a number of different possible career options in here for all people, from systems analysis to a software engineer, computer programmer, designer. This says system design here, but this would be where web designers do their design and web developers do their work in the implementation. So, if you're a little more familiar with that. So it goes through the whole thing. This is going to go through the whole process again, explaining what I said, which is a formal process that seeks to understand the problem and document in detail the system software that needs to be created. Most of the examples in this book are simple, and their requirements are clearly stated. Yeah, so most of these books don't do the process justice. It can get very, very complicated. Analyze the business process in terms of data flow and to identify the system's input and output. Fairly traditional definition. Part of the analysis entails modeling the system's behavior. The model is intended to capture the essential elements of the system and to define services to the system. Yeah, I mean, it's all basically on the analysis. It's all, done mostly on paper. You may use Visio design documents. This phase involves the use of many levels of abstraction, decompose the problem into manageable components, identify classes and interfaces, and establish relationships among classes and interfaces. That's a very object-oriented definition. They don't talk about the database design at all, which if you're doing software, you can have that. They don't talk about the user interface. Yeah, that's a very object-oriented definition of design, but design is actually more complicated than that, because there are different types of design, and there's a database design and the workflow analysis, but they're talking about Java, which is an object-oriented language, so I guess that makes sense. Design. This is sort of a very traditional definition, IPO, which stands for Input Process Output. Traditional, I mean, and most systems to this day still work that way. You input something on a keyboard or a mouse or even if it's your smartphone or whatever, there's a program that processes what you inputted, and then you get something back. And that something back in the past would be some sort of output on your screen or a printout maybe. Today it might be an email, and maybe an instant message or a text message or something. But the whole basics of the way programs work, of input, process, output, that whole thing really hasn't changed much. So yeah, that's not initial public offering. Thinking about anything. It's input, process, output. Implementation. Process of translating the system design into programs. Separate programs are written for each component to put to work together. Yeah, so that's the functional versus the integration. This phase requires the use of programming language like Java, like I said. The implementation involves coding, testing, and debugging. Right. Testing. Usually an independent team of software engineers not involved in the design and implementation of the project usually conducts the testing. You can do it that way, but the better way to do it is to have a professional tester, QA tester. It's really the better way to do it. So, and that's when I worked down at Apple, that's the way we did it. And the software we wrote was very, very good. Deployment. And of course, with testing, they don't talk about the different types of testing, which they're, so I think the author doesn't know that much about testing. First of all, software engineers shouldn't be doing the testing. And second of all, there should be 3 levels of testing. Although I think he kind of includes functional and integration testing in the implementation, because he says about putting the different components and then putting them together. That's essentially functional and integration testing. But it really should be here, not there. And this should be done by the users or professional testers, not by other software engineers. There's an old saying that software engineers make the worst testers because they know how it should work. So anyway. Deployment makes the project available for use. So for Java applet, this would be installing it on the web server. For Java application, installing it on the client's computer. Just essentially installing the program wherever it needs to be installed so then go live with it. And maintenance. Concerned basically the process of something goes wrong, you find a bug, or the user needs a change of some kind made. And there generally are periodic upgrades, maintenance releases. If it's something major, you kind of go back almost to the beginning and start over again. Okay, questions on the software development lifecycle. It's a good one.